Well, yes, students, good morning. In last video on simple harmonic motion, I told you the characteristics of simple harmonic motion and equation of motion, and I told you that simple harmonic motion is the projection of uniform circular motion on any diameter of this uniform circular motion. X dash or y dash. Here body we have taken moving anti-clockwise. If this is theta, theta is equal to omega t, and then this is y, op. Actually, I told you when body move on circular path, projection move on diameter. We can take projection on x-axis or any diameter. And the equation for like this: y equal to a sine omega t. If we take y projection on y-axis, v equal to a omega cos omega t, and alpha equal to minus a omega square sine omega t. So these are the three equations. By knowing these three equations, we can find other things also. Now, I told you when theta omega t vary from 0 to 180, then a come positive. When 180 to 360, negative. And here negative positive means change direction, opposite direction. If left to right taking positive direction, then right to left negative. I told you that simple harmonic motion is a motion which is periodic and takes place to and fro about a fixed line, straight line. So this projection point, this motion projection point here will be simple harmonic, not this circular motion. In this equation, omega is called angular frequency. So here I have written heading is phase and phase difference. This is very important term in this chapter and coming chapters. So in equation y equal to a sine omega t, the argument of sine, that is omega t. This is called argument of sine. Is called phase of the wave. Now you say, okay, mathematical, what does it indicate? Why we are having this heading here? Actually, I told you, since omega t decides here the direction of displacement or position vector, because we can call y as displacement or position vector of body performing SHM. Direction of acceleration, of displacement, velocity and acceleration. So it is called phase. Means phase in any simple harmonic motion is that quantity which gives the direction of displacement, velocity, acceleration. Here it is the phase acceleration. If I write it, y dash is another displacement a sine omega t plus pi 180 sine 180 plus theta minus sine theta. Then y dash will be minus a sine omega t. Means y, this y and y dash are exactly in opposite direction. Minus sign means it is known as that it is always pi, maybe pi by 2, pi by 4. So then there will be difference of direction. But if I take west to east direction, then west to east, east to west positive, so west to east negative. Now if someone is going at 45 degree from south to north, 45 degree north of east, then that has different angle. So that is called initial phase. बात करेंगे उसकी. So now come to here initial phase. So I told you the circle is called reference circle. Here when we derive equation y equal to a sine omega t at t equal to 0 body was here. At suppose x dash y dash. Now if at t equal to 0, point A is here at t equal to 0, and this angle suppose is phi, and in time t body goes to point P, and projection now come here. Sorry, P point is there at t equal to t. At t equal to t. So this angle omega t is turned. So displacement always measured from origin, center of circle. Center of, this is A here, I gave this. Now, how much is this angle? Omega t plus phi. So this angle will be also omega t plus phi. So from triangle OPB, y upon, I write OP upon OB equal to sine omega t plus phi, or OP is y or OB is A, radius A. So we got y equal to A sine omega t plus phi. Again this whole thing is the phase, but here phi is called initial phase. Initial phase. Phi is called initial phase. It is plus here. Then here in this equation, the motion, which motion is this? Simple harmonic motion. Motion is said to be leading in phase. Different people explain this different way also, but it is the most simple method of understanding. यानी कि already there were this much displacement, but total this. तो motion is leading phase. जैसे कि कोई पहले से चल जाए, कोई थोड़ी देर बाद चला हो, like that. Phi, it will be already find by how much time it will be taking. Now, but another way here, the particle may not be ahead of here. This particles may be here at t equal to 0.8 here, and this angle is phi. Then it will turn. Suppose it goes to point B at time t. So this is now this angle turn. If omega is the angular motion angular velocity of particle, then displacement is this. This will measure by this angle. So how much this will be? This will be omega t minus phi, and this is also omega t minus phi y. So in this figure, y upon a is equal to sine omega t minus phi, or y equal to a sine omega t minus phi. Here motion is said to be lagging behind. Lagging means to remain back. Lagging behind in phase. Here you may feel it unnecessary, but this is very important term here to understand the concept of wave. I will be telling you what is wave later. I don't want to waste time here. So that is called initial phase. And here this equation is said to be lagging behind in phase. So when we start a simple harmonic motion, then general equation, the general equation of displacement in general equation of displacement in SHM is written as y equal to a sine omega t plus phi or minus phi. We can find out value phi by knowing the initial conditions. Initial condition is at t equal to 0, what is y? At t equal to 0, what is y? I will be telling you the questions here. So we can find out it. But remember the characteristic of SHM. Don't think that this motion is yes or no. Projection of this motion, simple harmonic motion, always take place along a straight line to and fro about a fixed point in such a manner that acceleration proportional to displacement and has direction towards equilibrium position. I told you it is like this. भाई यहाँ पर ये बजाय अगर मैं ये ले लेता हूँ जैसे एक्स एक्सिस पर, तो ये मिड पॉइंट होगा, पॉइंट यहाँ, तो ये डिस्प्लेसमेंट एक्स, एंड आई फर्दर told you the general equation also taken as d2x upon dt square plus omega square y equal to 0. So body start here going this way, but acceleration alpha always towards equilibrium position. You must remember the direction of acceleration. Acceleration definition is that change in velocity per unit time. It is different from velocity. It is increase in velocity per unit time. And that in vector form we write this as v2 minus v1 upon t2 minus t1. And I told you the direction of acceleration is not along velocity, maybe along velocity, but it is determined by v2 minus v1. v2 minus v1 vector, direction of this will be along direction of A. जैसे कि मैं आपको बता रहा था कि body moving this way, here initial velocity v1 is this. v1 बड़ा होगा, v2 छोटा, क्योंकि इसको रेस्ट पाना है यहाँ, तो v2 minus v1, ये v2 बनाया और putting the tail of this on head of v2, we get this is v1 minus v2 minus v1, sorry, this will give you V2 minus V1. So remember, direction of acceleration is along the change velocity. There is one topic in class 11 I have taught, in which body moving with constant speed but has acceleration. When body moves on circular path with constant speed, that has acceleration, and direction of acceleration is not along velocity nor opposite to that. जैसे यहाँ opposite आ रहा है. You can say कि when it is coming back, तो V2 छोटा होगा और V2 बड़ा होगा, V1 छोटा होगा. Then it will be this way, V2 minus V1. V2 minus V1, then this come out this. So here it is along velocity. But I am telling you, there is one topic in which acceleration is at right angle to velocity. Circular path, centripetal acceleration. You know, I have explained very well. If you want to understand again, see the video in which I have taken centripetal acceleration. Okay, body moving this way, constant speed V, velocity along tangent, acceleration, इसको हम radial acceleration कहते हैं. तो remember that कि direction of acceleration is along change in velocity. Maybe along velocity, maybe opposite to, maybe at any other angle also. It is not necessary. अगर ये speed constant ना हो, if velocity keep magnitude velocity keep on changing here, then along with radial acceleration we will have tangent acceleration. Then direction will be at any other angle also. So I hope you will understand what is this initial phase. Now I come to next topic here. When any body oscillates simple harmonically, that is called simple harmonic oscillator. What is simple harmonic oscillator? The word is oscillator. Some people speak it like that, oscillator. No, it is oscillator. No? One my colleague madam keep on telling it is oscillator. I asked her why it is oscillator. Because sir, I speak like that. But that is not the way. Try to understand. Huh? Now in the next video I will come to total energy of simple harmonic oscillator. That is very important for further studies. Thank you.